Welcome back, ladies and gentlemen. Welcome back to the stream. Welcome back to my stream. As announced, we start now with our so-called Fields of Innovation. It's a special format, and the challenge for the guests we welcome right now is speed. They have to bring it to the point. The topic is industrial AI, and I'm pretty sure, although it's a challenge, our presenters are well prepared. Our first guest is the CEO of SENZORO, Mr. Markus LOINIG. And now, Mr. LOINIG, the stage is yours. Welcome.
Thank you very much, Christian. Welcome. My name is Markus LOINIG, CEO of SENZORO. I've optimized factories for more than 10 years. First at Daimler, later as a consultant, and now with SENZORO. And on the beginning of each project, I did always ask the production leader this question: what is the most annoying part of your job? And the answer was always along the lines like this: Markus, what really annoys me are the constant surprises of my machines. And it goes on. I just don't know when another vital part of my company, my factory, will fail. And I get these wake-up calls from my colleagues in the middle of the night. In order to help leaders like him, we did develop BeepMeep. BeepMeep is a smart maintenance system which uses ultrasound and artificial intelligence to predict failures in roller bearings and gearboxes. So how does BeepMeep work? BeepMeep is a mobile system, so you don't need to install permanent sensors. It consists of a rugged industrial tablet, which you can see on the left side, of a powerful ultrasound sensor in the middle, and you just need to place the sensor for a few seconds on the asset and start the measurement. AI will display a health score a few seconds later, which gives an indication if the bearing is okay or not. On the right side, you can see this bearing is fully okay because the max health score is 100. So there are many spooky things out there called AI. But in some cases, it's just a simple logic programmed by humans. So is BeepMeep really AI and highly innovative? So let me explain how it learned to identify damaged bearings. We did start our first ultrasound measurements 3 years ago. At this point in time, no one knew if this approach will work. There were just a bunch of research papers. At the beginning of 2019, we did have our first AI, which was able to identify a damaged bearing. And with more and more data, we were able to predict into the future. Meanwhile, BeepMeep has seen over 20,000 samples, and we have built the biggest database of its kind. In order to secure the data of our clients, everything runs on the tablet. So there is no cloud or internet needed. So who is buying BeepMeep? Our customers are manufacturers, machine manufacturers, and machine operators alike. Machine operators use it to reduce downtime and reduce their maintenance costs. Machine operators use it to upgrade their machines because they have a reliable and working solution for predictive maintenance. To give you one example, one of our clients is Holz. It's one of the major timber processing industries factories in Austria. So what is different there? This factory now runs with less surprises and with reduced change intervals. But the real cost savings is achieved by extending the lifetime of bearings. So whenever a bearing gets changed, we do also analyze that bearing and provide recommendations how to improve the lifetime. In this case, we did heavily work on lubrication, and this process did overall increase the knowledge of the team around bearings. Another example is from the paper industry, where slow-turning bearings are a major headache. And in a manufacturing line like this, you can imagine if one bearing fails, the entire line comes to a standstill. On the other hand, if you change it too early, it really adds up to your costs. So one of BeepMeep's specialities are slow-turning bearings. So we are currently active in Europe, focused on Austria and Germany, and we are now building sales channels around the world. If you want to know more about us, you can visit us at senzoro.com, and we do also have a YouTube channel where you can see many live demos. And maybe one thing, it's never the right time to start predictive maintenance, but the sooner you start, the greater your edge. I guess back to you, Christian.
Thank you very much, Markus. I mean, first of all, you really took it serious with the speed presentation. This was really rapid and speedy, but it was very understandable. And if I may say that personally, Beep Meep is a very, very interesting title because it reminds me on Meep Meep what the Roadrunner does in the Disney comics, and this is something that you remember. But I have a serious question, of course. You said that about 3 years ago you started with collecting data, and in those days it might have been a little strange to say, "Give me your data." Was that one of the biggest challenges, or what were the biggest challenges when you started?
Yeah, I mean, it's technology, so there were a lot of challenges, but maybe two stand out. So the first is actually how to get access to data. Yeah, so because it's a highly confidential place typically. But I've spent 10 years in the industry, so I had this network where I have access to factories. And the second is we do have our own hardware, made in Austria, so to speak. And same as with Apple devices, if you control hard and software, you can innovate very fast. You can integrate feedback from clients very fast, but it's very complex. But meanwhile, we figured it out how to manage both aspects of this solution.
Would you say, because you're an Austrian-based company, that there is more trust because Austria is trustworthy?
It actually helps a lot. Yeah. So Europe, Germany, Austria kind of helps to build trust. That's indeed true. Yeah.
So our European heritage works. I thank you very much for this vibrant presentation. Wish you all the best. And thank you very much.
Thank you very much.
Markus LOINIG, ladies and gentlemen. And now we switch to our next speed presentation. It's held by a company that is involved in detecting and predicting critical events. The name of the company is CRAFTWORKS, and we are very pleased to welcome its CEO. Welcome, Mr. Simon GRABHER.
Thank you, Christian. Hello and welcome. My name is Simon. I'm the CEO of CRAFTWORKS. We are specialized in industrial artificial intelligence. Today, I also want to talk about predictive maintenance. And first of all, I want to give you a short explanation of what it is. So manufacturers increasingly collect big data from IoT sensors in the factories. They store it on-premise, they store it in the cloud. And we can use it with different algorithms, and then we can use the collected data and detect warning signs of expensive failures before they occur. Why are we doing this? Well, because of we should increase the safety, not only of the employees, but also of processes and the supply chain. We should reduce outages, also reduce equipment and operational costs. Thus, we can in total increase the OEE and the ROI. I brought you some use cases, and the first one is about the district heating system of Vienna. Vienna has one of the biggest district heating systems in the EU. There are several thousand stations all over Vienna, and downtimes occur on a daily basis. And you can imagine if you have thousands of stations and several downtimes per day, you're really driving around Vienna fixing stuff. So we wanted to change this, and we used historical sensor data such as temperature and pressure. And now we can predict 7 days in advance when a converter station will be down. This really helps to be proactive, to really schedule the maintenance, schedule the people, and reduce the overall costs. The second use case is about detecting and predicting critical events. So high pressure causes permanent vibrations on hydropower turbines. And this can really become critical because the problems are immense. So what we are doing is we are using data from vibration sensors and try to predict vibration patterns. With those patterns, we can prevent the damages on machines and also the pipes. So I showed you two use cases which are mostly about the hardware, the machinery, and so on. But predictive maintenance is a first step to another use case, and this use case would be predictive quality. In the next use case, we are talking about press time optimization. And in order to have a stable pressing process and to produce high quality, it is very important to have an optimal press curve. The press curve is defined by the press speed and the press strength. So these press curves change over time. And the factors for this, or the reasons for this, can be, for example, tool wear. And this is where the predictive maintenance part comes in. And to really react on this, we created an artificial intelligence that uses process parameters like the press strength, press speed, and detect the changes early on. So we can really detect the change in the press curve and recommend process settings. So people at the machinery can really optimize the process during the production, and this leads to over 80 parts more pressed in 1 hour. So all in all, predictive maintenance is a very important first step into the right direction, into more quality and better processes. If you have any questions, please don't hesitate to get in touch. You can always email me at simon@kraftworks.at. Thank you.
I take that as an offer to ask some questions. Thank you very much, Simon. I mean, first of all, I think sometimes it would be also interesting to put sensor technique into humans to predict critical events.
Oh, that is...
I think my wife would be really delighted if she could predict some critical events if they occur.
We don't work on humans.
Why do you look at me like this? No, being serious, but what fields other than predictive maintenance, for example, can help industry companies to improve their processes?
Very good question. So basically everything about predictive quality, when you can improve the quality, reduce the scrap parts, you know, a thing that just goes to waste. So predictive quality is a very important part of what we are doing. Also, it is in high demand right now, because if you think about mass production, you cannot test every single part you're producing. So you only take some samples. And what we can do is have a constant quality assurance process over all the parts that are produced. So you always know what is the quality of every single part. That means your customers don't get damaged goods, you don't have some reclamations, and so on. Another part of predictive quality is also visual inspection. So you install cameras and you can really analyze every single picture, but not humans have to do this, but machines. And you can find anomalies, like if you're pressing metal parts on metal parts, you can see if there's too much glue, not enough glue, or if there's a part missing, and so on. So really there are a lot of options how to improve your processes and your quality.
So one can say predictive maintenance is also a question of sustainability, because you spare a lot of energy, you spare a lot of material, in fact.
Absolutely.
So it's a sustainable thing.
Yeah, and you can you save energy. You don't have to change the tools regularly, so you save on tools, and well, you optimize all the processes, less waste. Yeah.
Well, thank you very much. I think the presentation was optimized too, sharp, on the point. All the best. Thank you, Simon.
Thank you very much.
Now, our last guest in the field of industrial AI is specialized on data analysis based on artificial intelligence. Please welcome Mr. FRANZISKOS KYRIAKOPOULOS from Sevenlytics.
Thank you very much, Christian. Thanks for having us. I'm Franziskus. I'm the founder and CEO of Sevenlytics. We're a startup from Linz, Austria. Linz is, as everybody knows, the industrial metropolis of Austria and Central Europe. And we're a team of 20 experts, mainly from physics and mathematics. Our customers are large corporations in the German-speaking area from diverse sectors, industry, retail, media, and banking. And 2 of our customers actually are so happy with our solutions that they invested 1 million euros in us. So we also have gotten several awards over the last 4 years since our founding, and be it in hackathons or pitching contests or startup programs. And I mentioned that to show also that here in Austria we have a very good quality when it comes to artificial intelligence. As also my colleagues before me showed, we should not go to the United States or Asia. If we want AI solutions, we have enough know-how in this country to serve everyone. What we actually do now is that we take important use cases for manufacturing companies and other companies and put them in an AI software as a service. That means that we play the whole pipeline through end to end and deliver the result to the customer. There is no need to do anything else, no need to be an expert, no programming from the customer side. We go it through the end and one can see the results and benefit from the value of it. And one of these use cases, which is also, I would say, the most important one, is demand forecasting. So demand forecasting means that we want to predict how many items of each product will be sold across space and time. And this is important because in big corporations, a lot of departments depend on this question, or to the answer to this question. So controlling or production want to know on the long run how much we are going to produce, or for the short term, for the supply chain optimization, you need to assess how much quantity do you need to deliver from each product along the whole world. And we have done this use case for several industries, for clothing, for jewelry, for steel products, for agricultural machines, but also for beer. And this was the most fun use case to do in this case. What we do is we take historical data, but we predict the future actually. So we use machine learning algorithms that currently learn how to make a prediction about what is going to happen. And if the prediction is correct, then everything's nice. If the prediction deviates, they learn to optimize themselves. And if I have a good demand forecasting prediction, then I can also optimize production because if I know how much load my production facilities or machines will have, then we can adjust them better to be in an optimal control level. So this is what we do, and we have many companies have benefited from that, and I think it's quite important to just try it out and don't be afraid to engage in artificial intelligence. With that said, if you have any questions or interest, visit our homepage, our YouTube channels and social media, and I will be very happy to answer the questions coming.
Thank you very much, Franziskus. Of course, I have to refer to the thing with the beer. It just came up to my mind, although, of course, I have a serious question as well. I mean, I guess if there is a World Soccer Championship, the prediction of the overconsume of beer is not that difficult. No. Or on what does it depend? If when you do a forecast, how much beer is going to be drunk, what are the parameters you tell your artificial intelligence to look for?
Well, it depends in which area for Austria you're going to make the forecast, because as we know, each area has a different beer she likes and she drinks, and you cannot drink an Upper Austrian beer in, let's say, Tirol or Vorarlberg, and vice versa. Yes, everyone is a little bit biased, and we need to detect that. So this is one thing. Events, as you mentioned, they have a high outlier, and we need to take them into account, because it's not only how much at the day of a soccer match, but how much time before can you predict that good, so you bring the beer there. So there are a lot of factors coming in, and you need to take account of each of them.
I noted a question that goes like how important it is that the forecasting is really accurate, or is it just an estimate, or how accurate should it be, or can it be, to be really of value for the industry, the producing industry?
Well, this is a very good question, because there is no absolute truth. Okay, you cannot say like 99% all of the time. It depends on the data, and it depends on the business sector. It's different for steel as it is for beer, for example. But it should always be more accurate than the customer can do himself or herself, because else there is no incentive to use AI to do it. If I can do it in Excel, then it's not a big deal. So we ask actually our customers to give us a forecast that they would do, and we show them in a blind test that our forecast is more accurate. And there are different kinds of numbers. So we had in an industrial case with machines, the forecast had an error of 70%, and we brought it down to 5%, which is a huge improvement, of course, because then you can plan better.
If it would be the other way around, your system wouldn't work, but it does. Appreciate very much that you visit us in person.
Thank you very much.
Wish you a good day, and thank you very much, Franziskus.
Thank you also.
Ladies and gentlemen, this is not the end, but it's the end of our first block of the fields of innovation. You will have a short break now to decide if you will stay in this stream or switch to the other stream, but I can promise we meet again in a couple of minutes. Thank you for now.